Today I'm going to be showing how we can use the separation of variables to derive this top equation using the wave equation with Dirichlet boundary conditions. So we can assume that a function of u x t is going to be equal to a function of x times a function of t. For simplicity, I will be setting these equal to capital X and then capital T. So if we take the derivative with respect to x of u, we get x prime of t. So if we take the second derivative, we get x double prime of t. We can assume the same thing works in the t direction. So then we get u tt equals x double prime of t. So if we plug these back into the original heat equation, we get x double prime of t minus c squared double prime x times t equals 0. Now if we move the c squared term over, we get x t double prime equals c squared x double prime t. Now if we divide the t and divide the x to get equations of x and t separate, we get x double prime over x equals t double prime over c squared t. We're going to set this equal to a constant, which for convenience will be negative lambda. So we can solve for x first. So then we have x double prime over x will be equal to negative lambda. If we multiply the x by the negative lambda and then move it over, we get x double prime plus lambda x equals 0. Now, if we set negative lambda equal to negative beta squared, we can get the equation an sine beta x plus bn cosine beta x. Now, due to the initial condition, u of 0t equals 0 and u of lt equals 0, we can see that u of x times t, when x, the function of x, has the value of 0 times the function of t, to get a non-arbitrary or non-constant solution for t, x of 0 must equal 0. This goes the same for x of l. So, using the equation we already have, an sine beta x plus bn cosine beta x. If we set that equal and we have x of 0, sine of 0 is going to be 0. So this term can stay. However, cosine of 0 does not equal 0. It equals 1, which means the only way we could get a solution out of this would be if bn equals 0. So this term gets eliminated. So this is our equation, our general solution for x. Now, using the initial condition, we know that x of l equals 0. So if we put this into this equation, sine of bl must equal 0. Now, sine is only 0 when it is 0 or pi, or pi over 2, or any multiple of pi. So that means that bl must equal n pi. So if we divide over l, we can say that beta is n pi over l. So the solution for x would be an sine n pi over l x. So we can start to work on the t equation. So we have t double prime over c squared times t equals negative lambda. Now if we did the same thing we did with the x, we have t double prime plus lambda equal t, c squared equals 0. Now, we must also set lambda equal to negative lambda equal to negative beta squared. So, then we can have the equation and sine, the difference between this equation and the sine equation, the x equation, is that now we have this c squared term. So that's going to multiply by the beta. N c pi over L times t plus bn cosine n c pi over L times t. So if we put this together, because this is our solution to t of t, right? Put this together, we get the summation n equals 1 to infinity of, we put the t first, an sine nc pi over L times t plus bn cosine nc pi over L times t multiplied by, there is an an term in front of here. However, there are constants over here which get absorbed into the equation. So we can ignore the an term as it'll be present in the previous equation. So it's just sine n pi over L times x. And that is how we derive this equation up here. That'll help us solve for the heat equation. So we have right here 13a. So we have our general solution, which is going to be u of x comma t equals summation of n equals 1 to infinity of an sine nc pi over L times t plus bn cosine nc pi over L times t, all multiplied by sine n pi over L x. So from this equation, we can see that c is going to equal 1, and L, which is this, is going to equal pi. We plug this in, an equals, so if L is pi, the L and the pi will cancel out, and the c is left alone because it's just 1. So that'll all be sine nt. And the same thing goes for the b term, nt. And this is all multiplied by sine nx. So we can start with this initial condition, which gives us what happens when t is 0. So when t is 0, we have an. So when t is 0, sine of 0 is just 0. So the an term gets removed. And that will left from bn. When cosine is 0, it'll just be 1. So we can just erase that and assume that it'll just be constant there. That means we're left with sine nx, which is not affected if t is 0 because it's a function of x. So we get that it's equal to sine 2x. Now, the n equals 2. So when n is 2, so b2, there's a coefficient of 1 in front. So b of 2 is going to just be 1. Now, we also have the initial condition that when there's a derivative with respect to t, and as t is 0, should be 0. So, go back into the equation, and then we can get an. So if we're deriving with respect to t, that'll be negative n sine, wait no, that'll be cosine. cosine of nt plus bn, and that's going to be n sine of nt. Now, the outside does not really get affected because it is a function of x, so it'll still be sine nx. Okay? Then, when t is 0, cosine of 0 is 1, and because this function is 0, that means an must be 0 for all n. And then we're left with bn. Now when t is 0, sine is 0, so that would also be 0, which bn in this case would be 0. And then if 0 times whatever function this is will still be 0, so that's all 0. That means we're left with the equation u of x comma t must be equal to, when n is 1, when n is 2, b equals 1. So that'll be bn, which in this case would be 1 sine of 2x times bn is 1. So in this equation we see right here, or more simply down here, we have cosine of 2t. And this is our final solution. Now we will solve for 16a using the separation of variable method. So if we substitute c in our equation is 1 over pi, and L right here is going to equal to 1. So when we write the equation, we could say an, parentheses of course, sine, and then in here would be nc pi over lt. Since L is 1, then it's just nc pi. But because pi is 1 over pi, this is canceled. So all we're left with is nt. Same goes for when we go for bn. Cosine of nt multiplied by sine n pi x. So when t is 0, we have this equation right here, which using trig identities, we can simplify to 1/2 sine 2 pi x. So when solving this equation, and we substitute 0 in for t, our sine term cancels. Our cosine is equal to 1, so all we're left with is just that bn term, and then we're left with this sign out here, which means bn times sine of n pi x is going to equal to 1/2 sine 2 pi x. Correct? So that means when our n is equal to 0, when our n is equal to 2, b2 is going to equal 1/2. So, and as we can see, when u of t, when t is equal to 0 is just 0. So as what happened in the 13a, there is no other term there. So for our final solution, we plug in only b2. We have 1/2 sine 2 pi x times, because the bn term is attached to the cosine of 2t. And this is our final solution.